I'm Anil Kumar and we'll discuss concept of rationalization in this video. First thing is for us to understand what is rationalization. Let's begin by rational numbers. So what are rational numbers? That will help us to understand the concept. Rational numbers are numbers which could be written as quotient of integers, right? So these are rational numbers, right? So that means they could be written like a fraction, right? So integers. Now irrational numbers, you cannot write them as integers. Could be, for example, we say square root of 2. Now square root of 2 is irrational. We cannot write this in the form of p over q, where p and q belongs to set of integers. On the other hand, if I have square root of 4, I could write this as 2, right? Or 2 over 1, right? That becomes a rational number. So that is what our basic understanding about the number system. So in this particular exercise, when we say rationalization, what we're trying to do is we are trying to write irrational number like a rational number. So that is the concept. And the idea is like this, that if I have square root of a, and if I multiply square root of a by square root of a, and think square root of a is irrational, then by multiplying, what do you get? You get a. Do you get the idea? So it becomes a rational number. Similarly, if I have square root of a minus square root of b, and if I multiply all this by square root of a plus b, I mean square root of b, what do I get? I get a minus b. Square root a square minus square root b square, a minus b. So that becomes rational number. Do you see that? So that is rational. So this process of writing any irrational number in the form of a rational number is called rationalization, right? So from here you also observe that we are working on two different cases. One is we could have one term or we could have two terms. Likewise, in our examples, we will consider different kinds of examples, examples with one terms and examples with two terms. Now let me take few to begin with. Let us say we take a rational number 2 over square root of 5, 3 square root of 5. Now this is irrational number. Now what happens if I multiply and divide this number by square root of 5? Now in the numerator I get 2 times square root 5, correct? But in the denominator, square root 5 times square root 5 is 5, and 5 times 3 is 15. So what I get is 2 square root 5 over 15. So in that process, what have I done? So in this, I have rationalized. Which part? Denominator. In the denominator now, I do not have an irrational number. I have a rational number. So that is the process of rationalization. Let me take another example. Let's say we have 2 square root 5 divided by square root 3 plus square root 5. Now the denominator here again is irrational. To rationalize, I can multiply by its conjugate. Conjugate is like the one which when multiplied to this will rationalize it, okay? So that is the conjugate. And now how do we get the conjugate? The conjugate of square root 3 plus 5 will be square root 3 minus 5. So just interchange this sign, okay? So we multiply and divide by square root 3 minus 5, the conjugate of square root 3 plus 5. Now Since we are trying to rationalize denominator, we are multiplying and dividing by the conjugate of the denominator. Now when you do so, the numerator becomes 2 times square root 5 times square root 3 will give you 2 times square root 15 minus the second term is square root 5 times square root 5 is 5 and 5 times 2 is 10. So I'm skipping some steps which you should do, but that is what you get. The denominator will be a square minus b square, right? So it will be 3 minus 5 in this case, 3 minus 5, which is 2. So now you get 2 here. So okay, let me extend this. I thought I'll finish it off there, but we can still simplify. So we have 2 square root 5 minus 10 divided by 2. Now we can take 2 common factor from the numerator. Let me take like this, minus 5 divided by 2, and simplify and write it as square root 15 minus 5. So that is how you can rationalize the denominator in this case and do the needful. Now it is important to note that there are times when we rationalize numerator, right? For example, if I have an expression square root 5 over, let us say 2, right? And I want to rationalize numerator, I will now multiply by square root 5 over square root 5 and get 5 over 2 square root 5. Do you see that? So in this case, I have rationalized numerator. So there will be examples where at times we will rationalize numerator, right? Not the denominator. Well, we will have examples where we are going to rationalize both numerator and denominator also, okay? So let us take an example like square root 2 minus square root 3 divided by, let us say square root 5. And if I have to rationalize the numerator, I'll multiply by the conjugate of numerator, which in this case is square root 2 plus square root 3, and also divide by the same thing, right? So what we get here is 2 minus 3 divided by, when you multiply by square root 5, you get square root 10 plus square root 15, correct? So which of course is, let me continue, minus 1 over square root 10 plus square root 15. You get an idea. So that is what is rationalization. We are going to explore it further, and I have a lot of examples which I am connecting with this video. I'd like you to go through those examples and practice rationalization, as that will be key in solving many calculus problems, especially when you're working on limits. Thank you and all the best.